So dear students, in today's video, we are going to discuss this differential equation. So as you know, in this playlist, we are working on first order linear differential equation. In a complete playlist, we have discussed various types, right? Reducible to linear type 1, type 2, type 3 we have discussed, and we have discussed several examples based on that. So it is one of it. So before starting this example, let us revise all these methods, all these types, okay? And let us see how to decide. So if you have such random problem in examination, right? Let us see how to decide which method we have to apply. The given problem belongs to which type, okay? So let me write here dy by dx plus py is equal to q. So this is a standard form of first order linear differential equation where p and q are functions of x only, right? So after that we discuss reducible to linear type 1. Reducible to linear, that means the differential equation is not linear exactly, but you can reduce it in a form of linear differential equation. So type 1 was, okay, dx by dy plus p dash x is equal to q dash. So what is the difference between the previous one and this one? Simply x is replaced by y and y is replaced by x. This is the only difference. You can see here dy by dx, dx by dy, p and q are functions of x here, and here p dash and q dash are functions of y. This is the only difference, right? Type 2 also we have seen, type 2, which is f dash of y dy by dx plus f of y p is equal to q, right? So this is type 2 reducible to linear. That means using one substitution, f of y is equal to u, we can convert this differential equation into first format, right? So that is called type 2 reducible to linear differential equation. Let us see type 3. So in case of type 3, we have f dash of x dx by dy. Simply we replace x by y and y by x plus f of x p dash is equal to q dash. So here p dash and q dash are functions of y. Okay, so this is all about first order linear differential equation. So we have covered all these methods. We have discussed several examples based on that. So let us talk about this problem now. Okay, so what do you think it belongs to which type? Okay, so if you have such random problem and suppose you know all these methods, you have already prepared the methods and all these things, right? So let us see how to decide the given problem belongs to which type. In a given problem, we have dx by dy. So out of these four methods, okay, or out of these four types, just in type 1 and type 3, we have dx by dy. That means the given problem belongs to one of these two types, right? So in both types, we have p dash and q dash, which are functions of y only, right? P dash and q dash. Here also p dash and q dash. It means in the right hand side, we must have function of y only. But in a given problem, we have some function of x also, which is cos square x. So I don't know right now it belongs to which type. It will be either type 1 or type 3. But apart from that, it is fixed. In right hand side, there should be a function of pi. So I'm trying to bring the same term there in a right hand side, function of y. It means we have to remove this cos square x. So that's why I will divide both sides by cos square x. Dividing both sides by cos square x. Okay, so it means y sin x upon cos square x dx dy. To middle term also I will divide. See, minus sign is there, na? Minus cos x upon cos square x. So this is equal to 2y cube. If you divide by cos square x, it will get cancelled, right? Okay. So let us simplify it. Y sin x, cos square x, it means we can write cos x into cos x. Agree? It is cos square x dx by dy. Here what will happen? One cos will get cancelled. We have one cos at numerator, one second cos at denominator. It will get cancelled. It means we have just 1 upon cos, which is sec x. Getting the point? So let me show here. I am cancelling one cos. but still 1 cos is there at denominator. So 1 upon cos means, sorry, sec. 1 upon cos means what? Sec. So that's why we get a sec x here. Let us talk about the first term. Y. Sin of x upon cos x is tan x. And 1 upon cos means what? Sec x. Okay. So this is dx by dy minus sec x is equal to 2y cube. So finally we brought that function of y in right hand side, right? Function of y, function of y. That's it. So let us adjust the previous terms now. So dx by dy we want, getting, and here dx by dy, and we have some multiple of x, getting multiple of this dy by dx, which is f dash of x. So I think it belongs to type 3 because dx by dy we have some multiple of x. But see, another thing, that there is no any y, we have the function of x only. That means we have to remove this y also. So for that I need to divide the entire differential equation by y. So dividing both sides by y, let us see what will happen. Dividing both sides by y. So this y will get cancelled. Tan x sec x dx by dy. Let us divide it by y. So sec x, right? Sec x divided by y. And if you divide this right hand side by y, it will be 2y square. 1y will get cancelled. Okay. So let us see it fits to type 3 or not. Q dash function of y we have here. P dash again function of y. So 1 by y minus 1 by y we have here. So that's why that is P dash. F of x function of x. So we have a sec x here. And here f dash of x. Whatever the function we have, its derivative should be the first function, getting a multiple of dx by dy. Here f of x is sec x. What is its derivative? Sec x tan x, which we already got here. That means definitely it belongs to type 3. So we have to follow this method to solve this problem, right? Okay. So in this case, in type 3, what we do? We put this f of x is equal to u. This is very simple method. What we do? What we put f of x is equal to u. So let me write putting. What is f of x? F of x means here sec x. So that's why I'm writing sec x is equal to u. So in case of differential equation or in case of integration, when we put anything, the first task is to find its derivative. So let us find derivative. Derivative of sec x is sec x into tan x, but again derivative of x with respect to y, so dx by dy. In right hand side also I will take the derivative. Derivative of u is du by di. We are differentiating with respect to y. You can see here dy, okay, in denominator. It means we need to differentiate with respect to y. I got this one. Let us move further, okay. So let us put a value here. Let me call it as equation number 1. Then 1 becomes, so see what will I get? 1 becomes tan x sec x dx by dy will be replaced by du by dy. Du by dy minus sec x means u upon y is equal to 2y square. Okay, 2y square. That means using this substitution, we converted a problem into type 1. Okay, now it belongs to type 1. So you can see dx by dy, du by dy. At a place of x, we have a u. Remaining part is same. X, we have a u here. P dash function of y. So here function of y is minus 1 by y. Q dash function of y, which is 2y square. So it belongs to type 1 now. Using this substitution, we converted this problem into type 1. So let me note down what is my P dash. So P dash is minus 1 by y. And Q dash is equal to 2y square. Okay, right hand side. Let us move further. Okay. See, now just 2 steps are there to get the final answer. The first step is to find integrating factor, and the last step or the second step is solution. Directly we have a formula, we put it there and we get a solution. So if you have already seen my previous video, you are very used to it. Okay. So if possible, try to say, okay, try to say before writing on the board. Okay. See, integrating factor. It's e raised to integration p dash dy. So this is equal to e raised to integration. P dash is minus 1 by y dy. See that minus 1 is a constant. Will come outside. 1 by y dy. Do you know the integration of 1 by y? It's log y. It's log y. Okay. So generally when you have exponential function and log, they get cancelled to each other. But here we have a problem that minus sign is there. We need to remove that minus sign. Then only we can cancel a and log. Now the question is how to remove that minus sign. So there is one property of log, n log a. So n log a is log a raised to n. When you have any multiple of log, you can shift it as a power of a. I will do the same thing. So this is equal to e raised to log. This minus 1 will go as a power of y. Okay, so y raised to minus 1 we got there, but no need to worry since exponential and log will get cancelled now. And what will you have? Y raised to minus 1. That means simply 1 by y. Yes, so it is 1 by y. So finally we got integrating factor. Now just we are one step away from the final answer. So let us write the solution. Formula is fixed. Solution is u e raised to integration p dash dy, integration e raised to integration p dash dy, q dash dy plus c. So this is the final answer, right? Actually in the formula we have a x here, but now we have a differential equation in terms of u, so that's why I wrote u there. If you want, you can put the original value of u, which is sec x. So let me write sec x. Value of exponential function e raised to integration p dash dy, which is 1 by y. Here also its value same, 1 by y. Q dash, what is my q dash? 2y square dy plus c. Okay, so right now there is no more space to solve the remaining part of this problem. Just make a screenshot of it, then I will move further. So let us simplify it. Okay, so let us see what will I get. Sec x, this y is in denominator, so we'll have sec x upon y, right? Integration. So what will happen? One y will get cancelled since one y is in denominator, one is numerator. Y will get cancelled. 2 is a constant, will come outside. Y dy plus c. So what is the integration of y? So see this formula I'm using, x raised to n is x raised to n plus 1 upon n plus 1. So when you have x raised to n, simply we add 1 in its power and the same number will be in denominator. So power is not there, so power is 1. Okay, let us use this formula. So we add 1 in power, so 2 and the same number in denominator plus c. So 2 will get cancelled, agree? 2 will get cancelled, and so let me write the final answer. Sec x upon y, this is equal to y square plus c. So this is the final answer of this given problem. Okay, so we got the final answer. So in this way we finish this problem. Okay, in next video I'm going to cover Bernoulli's differential equation. Okay, so if you want, you can watch my next video. Thank you. See you in next video.